Good morning, good evening, good afternoon, wherever you are watching us. I'm very excited today to talk with Nader David, and actually, Nader was the our last guest before pandemic hits, and the it was on January, right? January 2020, and yeah, and he was in Istanbul.
Yeah, I was in Turkey.
Yeah, he was working on the completely different things, not completely, but like quite different things. And he was here for a what was that? The connection, like connections, environments, the applications using Amplify, right? Like it was a great presentation as far as I remember. And I'm now again very happy to host him as like now we are talking about the decentralized web again with serverless. I'm quite interested in this subject recently, and it will be great. So Nader, it's you.
Awesome. Thank you for the intro, and yeah, really glad to be here. So what I'm talking about today is probably going to be way different than anything that maybe has been presented here, and it's also kind of somewhat new to me. Really, I've only been diving into this exact area for the last 7 or 8 months or so, but I'm always very interested in serverless. Ever since I started, kind of understanding, how the benefits are and working at AWS, and became fascinated with the idea of serverless, not just functions as a service, but the serverless spectrum, which I'm going to talk about later. Um, and like while I was at AWS for a little over 3 years, I really, learned a lot about, building serverless applications, and again, kind of really got sold on this idea of managed services. So when I started diving into the decentralized web and kind of like some of this future facing ideas around building a more, I would say, kind of a new way of building applications that a lot of people call like Web3 or the decentralized web. I started realizing that there were a lot of characteristics that were shared between some of the ideas that we valued at AWS within the serverless team, along with a lot of these services that I was working with. So that's kind of what I want to talk about today. I want to share some of the ideas there and kind of how they relate, I guess you could say, and then how you might actually build out some of this serverless architecture in a decentralized manner. So with that being said, I'm going to go ahead and share my screen so I can go ahead and start with my presentation. All right. I'm hoping that everyone can see that okay. And if they can, I will go ahead and continue on. Let's just see here. Yeah, it looks like it's being shared. Okay, cool. So yeah, thanks for the intro. My name is Nader Dabbit. I've been working in developer relations for like 5.5 years or so. Before I joined the Web3 space, I was working at AWS for over 3 years on the front end web and mobile team, focused on AWS Amplify, AppSync, doing a lot of CDK and stuff like that. And I wrote a book on serverless called Full Stack Serverless about a year and a half ago. So with that being said, the title of like this presentation is called Decentralized Serverless Web Protocols. And I want to talk about how a lot of these ideas of serverless are also, you could say, characteristics of some of the decentralized protocols that I use every day now that I'm working in the decentralized web space or the Web3 space or, crypto space. So with that being said, like what is the decentralized web? Well, the main characteristics are around this idea of decentralization. They also apply to the types of applications that we're building, and I'll talk about some of those characteristics in a moment. But kind of like the idea is, in essence, we have this kind of evolution of how we've built applications. In Web like 1, Web 2, and Web 3, you kind of have this partition of different ways that we think about how applications were built. The early days, it was kind of like a read-only web, and we had a lot more focus on these decentralized protocols. But there was a lot of limitations there. The only people that were creating things were developers. So if you wanted to kind of like be a creator, you could not typically interact with the website. You could only read things off of a website. And then the current state of the web is often partitioned into kind of like Web 2, where it's an interactive web where anyone can be a creator. You can go to a website or an app and upload an image or a photo or a video or even a blog post. And it's a lot more interactive and things like that. And then kind of Web3 is kind of taking the good characteristics of Web 2 and maybe improving a lot of the negatives that we have. And this goes beyond the scope of this talk, but it's kind of trying to address the issues around privacy, around data harvesting, around surveillance capitalism, and things like that. So how do we build out, I guess, these decentralized web protocols? What do they look like and all of these things? So let's take a look at that. So before we kind of look at the current state of like what decentralized web looks like, I think it's smart to take a step back and look at the reason why the internet has done so well, in my opinion, up until this point. And a lot of people will claim that the internet has thrived because we have all of these native protocols that we use every day that we've become like accustomed to as developers. So you might think of these protocols like HTTP, FTP, TCP, SSH. One of the reasons that these protocols have been so successful is that they're widely adopted and they're not subject to change. So if I build a site using HTTP, I know that anyone in the world can use it without having to deal with any centralized intermediary. We can just trust that it's going to work. Now, these protocols were great, but they're limited because they essentially just give us the ability to upload text files, attach addresses to them, and then make them accessible. But there were major pieces of functionality that were kind of missing out of the tech stack that is native to the internet up until now. And to get around that, we've kind of built out a lot of very, very complex, wiring and infrastructure to make these things work. And that is essentially kind of native payments in native state. So when you think about native payments, what does that actually mean? Well, if we want to send a payment from one party to the other, imagine all of the underlying infrastructure that needs to be in place for that to happen. So if I want to send my cousin in Palestine $50, the actual underlying things that have to happen to make that work are actually very, very sophisticated. So first of all, I have to walk or get transportation to go to some government authority to get an ID, and I have to bring some paperwork there to get that ID. Then I have to take that ID and I have to get transportation to go to some bank. And at that bank, I have to also bring additional information about myself, as well as probably some money to go ahead and open up that account. Once I have that account open, I need to then go to the internet, create an email address. Using that email address, I will then take the bank information as well as my email address and find some online place that will allow me to create an account like with PayPal or Stripe. Once I've done that, I connect my bank account, and then I'm hoping that the other person on the other side of the world was able to do all that stuff as well. And then I'm hoping that also that the two different companies that we decided to use for payments actually work together well. Well, guess what? Most of the time, these things are not, actually going to be working so well, especially across international borders. So to get to kind of get around that, we've, what we've tried to do so far is build all this complex infrastructure. We have Stripe, we have PayPal, we have, Square, we have all these different monetary, software corporations that have sprung up trying to fix this. And while they do serve a purpose, but they're, again, very complex. Imagine instead, I can just go to open my web browser, download an extension, get a public key and an address, and then give that address to someone on the other side of the world, and they can send me a payment with one click. That's kind of where we are today and with the state of blockchain and cryptocurrencies. There's no gatekeeping. There's no centralized authorities stopping people. Like, for instance, there are over 70 countries that have laws in place that prevent women from being able to open their own bank accounts and things like that. Like, all of this gatekeeping is kind of essentially sidestepped with native payments that are now made possible via blockchain technology. In addition to that, native state. So like, how do we actually store information on the internet today? Well, it's not built into the internet. Instead, we have to create a server or buy a server and create like a database locally in our garage, and we kind of like, make that accessible via an API. Of course, nowadays we use cloud providers like AWS or GCP, and they work really well, but all the underlying infrastructure is very, complex, and it's somewhat brittle. You'll often see some of these things, they just go down for whatever reason. Yesterday, of course, like US East 1 goes down and shuts down half of the internet. So, to get around all of this, the lacking of native payments in native state, we've built out very brittle, very complex infrastructure. So the future and the ideas around kind of the improvements there kind of have to do with this idea, like, what if we could have decentralized networks that allow us to kind of have the ability to programmatically run code and store state that even if like half of the servers in the world go down, our application still works. So the decentralized web can be thought of as the stack of protocols that enable fully decentralized applications. And these protocols are the ones that I want to talk about that I kind of bucket as serverless. So what kind of applications are people building using these technologies? Well, they have a certain set of characteristics, and they just essentially allow you to build, of course, some of the same applications that we built in the past, but most importantly, they just open the door for new types of applications to be built. So I don't think that people should look at kind of like these new technologies as a replacement for what we had before. They might do that in some circumstances, but in reality, it's more like we now have the ability to build new types of applications. So when augmented reality and virtual reality came out, a lot of people were like, "Oh, this is going to replace like mobile or whatever." Like, it did not do that. Instead, it gave us like new ways to build cool stuff. You have machine learning that opened the door for new ways for us to build stuff. Mobile did not make desktop go away, and instead we now have new ways to build stuff. I think decentralized web, blockchain just enables you new ways to do stuff. And I think that there's nothing wrong with kind of learning all of these new technologies if they seem interesting to you, so you get the door opened up to build applications that are decentralized. And the characteristics are kind of listed here, some of the more popular like talking points and reasons why you might be interested in this technology. A lot of the applications and the organizational structures enable ownership, not only of the data, but of the platform. So for instance, if I build a following on Twitter right now, and Twitter decides one day to just like ban me or whatever, I have no way to kind of take all of the work that I've built up over the course of the last couple of years and port that over to somewhere else. But with most of the ideas around these decentralized public backends, that data is completely public and open for anyone to build upon. So you end up having this idea of a public and open backend that you can port your data between applications, but also any front-end developer or any company, any team can build out additional user interfaces on top of all of these backends. So you're seeing a lot of this already happening in decentralized finance, as well as NFT marketplaces, but I think you're going to start seeing it happening in other areas as well. I've already mentioned native digital payments. So the ability to send payments in just 2 or 3 lines of code is kind of fundamentally like groundbreaking and I would say disruptive compared to what we used to have in the past, all of the complexity around payments. So what if it was that easy for people to kind of build payments into their applications? You now are opening the door for a lot of new ways to build stuff. Self-sovereign identity is a big part of the decentralized web. If I use an application today, I typically have to hand over my personal information, my email address, my phone number, my address, even my social security number. And often that data is tied to my usage of the application. So they start storing all of this data around who I am and what I've done and all these things. And then you have these data breaches. So, and then you do this across dozens of applications. So like every time you sign in with Google or Facebook, you probably are now storing your information on another database somewhere. So now you have your personal information stored across hundreds of different applications. You have data breaches. You have websites that are dedicated to just showing you all of the times that these companies have screwed you over. The idea in Web3 is that you're having a different way to identify yourself, typically around public key encryption. So instead of having to sign in with an email address, you sign in by signing a transaction using public key cryptography, using what we call wallets, but in reality, it's essentially just a private, it's a seed phrase that mathematically derives a private key that mathematically derives a public key that then gives you your address that you can use to identify yourself. And at that point, you can choose to attach your personal identity to that address or not. And it's not up to the platform that you're using. It's kind of up to you to whether you want to turn over that personal information or not. But I think the most important thing as it relates to this discussion is this idea of distributed, trustless, and robust infrastructure. So when we think about how the different characteristics that we like about serverless are, one of those things is that we kind of have the ability to not have to deal with managing the infrastructure. It's kind of managed for us. We can just worry about writing our business logic. We can worry about writing our, our custom code that kind of makes our application different than everyone else's that delivers that business value. And we don't have to worry about if the application goes down or whatever. But that being said, even with the stability that serverless infrastructure gives us, we still see instances where we have reliability issues. So again, going back to kind of like US East 1, how it often goes down, these things happen still. So one of the big, I would say, strong points around some of these decentralized protocols is that you don't just have your infrastructure running on a single server and a single point of failure. You instead have them running on dozens, hundreds, or even thousands of nodes. And all of these nodes are keeping up with shared state between them. So if one of them goes down, you can still interact with your application. Your application does not go down. So that's kind of like the main thing I would say that we're going to focus on right now is this kind of like idea of distributed, trustless, and robust infrastructure. So in the past with a centralized system, we typically have this idea of a single point of failure. So even if we're using AWS, like you often don't really see people replicating their infrastructure across multiple regions just because it's so much work to do. And often it's just not easy to do. But what if this replication was built into the system by default and you didn't have to actually do anything? A lot of these public decentralized backends have this built in natively, and that's just how they work. So that's a really good benefit of kind of like building in this manner. You automatically have this distributed nature of your infrastructure. It's kind of like just how it is, and you don't really have to deal with it. It's kind of like part of the system and it's managed for you. So like with that being said, let's kind of take a step back and look at this idea of what serverless even means at this point. And one of the people that I like to read the most about serverless, who's been writing about it since like 2016, really early on, is Ben Kehoe. And he wrote this post called The Serverless Spectrum. And instead of like us saying this is serverless or this is not serverless, instead he argues that you kind of have like a spectrum of serverless, meaning like something that is completely managed is probably more serverless than something that you have to manage partially. So you kind of like have these different things that you're doing and they fall on this spectrum of how serverless that thing is. And one of the things he kind of like tries to give a description of or a definition of is like, what does even serverless mean? And he says for it to be more serverless, it needs to move in the following directions, one or more of the following directions: service full plus ephemeral compute, tighter correspondence between resources used and resources billed, and a smaller and more abstracted control plane. But I think most importantly, like during this time, we started seeing the definition of serverless move away from functions as a service and instead more on a way to focus on business value. And you started seeing the definition of serverless, at this time and a few years ago, moving away from, we're not really, serverless no longer is just like serverless functions. It's now more like managed services, or again, in this case, a way to focus on business value. So with that definition, then you can then go back to this decentralized web. Most of actually all of the applications, for the most part, when you're thinking about like blockchain protocols, are that are running, arbitrary code, are smart contract platforms. And because they give you an API that you don't have to kind of manage yourself, that just is given to you, and you're kind of like constrained within the definition of what that API is, then you could easily argue that smart contract platforms are serverless. Going beyond that, looking at other different decentralized protocols, like decentralized storage protocols, they are also serverless. In fact, I'm going to talk about a couple of these in a moment, but you even have teams building S3 compatible APIs on top of these decentralized storage protocols. So you're given like an API and you store data there, and the data lives, and you don't have to kind of manage it. It just works. But it is also often you're given capabilities that I'm going to talk about in just a moment, that you can't really get in a centralized world. So for instance, if you stop paying your S3 bill or something like that, then your data is lost and it's no longer there. In the decentralized world, we have protocols like Arweave that store your data infinitely, meaning that you store and you pay your transaction for that data one time, and you never have to pay for that cost again. It just lives there forever. That's very similar to a blockchain. When you write a transaction, that data is there forever, and you can now read that data forever, and you don't have to pay any more money for that. And you're given, again, like this API that you're working with, and it is defined for you. You use it. You don't have to worry about who built it or how it works. You just know that it's going to work. And you also know that it's always going to be there. So Ethereum has never gone down, I believe. I think there might have been like one network issue at some point a few years ago, but for years, you can depend on this application being there and this data being there. And then going beyond just smart contract platforms and decentralized storage protocols, you could also argue that almost all decentralized web protocols are serverless. And I'll talk about some of these web protocols in just a moment. But I would say like the godfather of all web protocols, these decentralized web protocols that allow us to perform compute, is Ethereum. And the founder of Ethereum is Vitalik. And he even has said back in 2020, people who say full decentralization is overkill, you only need non-custodial, or missing the point. A fully decentralized or serverless application is valuable because it gives users the confidence that it will always be there, so you can safely build on top of it. Now, this is very, very important, because now we're even moving past this idea of stability, because yes, we care about stability and we do want our application to be up and running all the time. But if USEast goes down like once a year, like who cares, right? But what if instead we have the stability to know that 5 years from now, all of our data and our API is going to remain the same, and 10 years from now, the same, and anyone can build upon it? That kind of changes the way you might think about building applications, because at that point, you're not competing on your backend infrastructure anymore. You're now also instead allowing anyone to kind of compete on the front end of the backend. So you have your backend that you've built in a smart contract or whatever. You have your data there and all of that, but anyone can now build upon that, because we know that it's always going to be there, and we know that it's not going to change. So going back to these web protocols like FTP, HTTP, and all this, we know that those protocols are not going to work, and that they are going to work, and they're not subject to change. So we've innovated on top of those protocols, and now I think we're starting to see people innovating on top of these decentralized web protocols, because if I see someone has built a cool smart contract, and I have an idea for what I can do to kind of maybe improve the user interface on top of that, maybe I can then take that smart contract along with a dozen others and build out some new application. And I don't have to worry about the backend implementation. I can allow my users to write transactions to that. It's not really owned by anyone. It's permissionless. So that's kind of like the fundamental big, in my opinion, breakthrough when I started learning all this stuff. That kind of blew my mind. And I will say that these protocols this way of building applications isn't for everything. It's just for certain types of applications. So you wouldn't want a public backend for something like a private messaging service. Obviously, you would not want it for types of applications that don't make sense, right? But there are a lot of really interesting use cases that you could think about this building stuff like this. So what are these types of applications and protocols? Like, what are people actually building with this stuff? And then what do these protocols look like? Well, the types of applications that people are building typically have to do with some type of financial element to them. They often have to do with really an important focus on immutability. Like, you want to have some data and you want it to be immutable. Those are two big characteristics. So therefore, you see a lot of decentralized finance, DeFi applications, and stable currencies. Those types of applications are often used like in the decentralized web. So using these financial primitives, you can do all sorts of stuff. Decentralized web infrastructure protocols, which we're going to look at in just a moment. Gaming, so the ability to allow users to earn within a game or to hold on to assets that they've won within the game and port them between games. Those sorts of innovations are happening already. So if you think of something like Fortnite, where you pay hundreds of dollars a year for skins and currency, you can't really take that outside of the game. But now we're seeing the application of blockchain technology with NFTs and digital currencies within the game that do allow people to take that investment they have and then port it between games or even sell it back to other users within the game. So a game like Fortnite, 100% of the money goes to the platform. Instead, you have games like Axie Infinity or a handful of other ones where 95% of the money goes back to the users and only 5% goes back to the platform. So users are provided with like new incentive mechanisms and stuff like that. You have DAOs, decentralized autonomous organizations. You have digital art. Also, people talk about NFTs. You have this idea of tokenizing physical assets like real estate, also tokenizing companies. So in the old world, you might spend 8 years building out a company only to realize that you can't take it public because some competitor came around and essentially built something better than you, and you've wasted a lot of your time and your life. Instead, today, you can decide, okay, I have a good idea. I want to onboard a lot of early contributors and investors, and I want to go ahead and launch my own token to back this project. And you can get immediate liquid investment from day one, and it just kind of changes how people are starting to build companies. And I think you're going to see a lot more tokenization of not only physical assets, but also businesses and things like that. And then, of course, you have people like trying to take traditional applications that we've had before and turn them into kind of like decentralized apps. Some of those will work, some of them will not work. You do have platforms like Audius, which are a decentralized Spotify. You have platforms like Mirror, which is the decentralized blogging platform, and so on and so forth. So how do we build out some of this stuff? Well, I'm going to talk about one in depth, and then I'm going to kind of gloss over a few others, and then I'll try to build out a demo. So the team that I work the most closely with, and therefore I'm going to talk the most about, is the Graph protocol. And this is a decentralized web protocol. And it's a protocol for indexing and querying data from networks like Ethereum and IPFS, but really almost any Ethereum virtual machine compatible network. So there are a few dozen of these. So, Ethereum is built on this idea of the Ethereum virtual machine, which is you could say like an execution environment. And it's also a protocol that allows smart contracts to run. And you've seen other people build out other blockchains using the same implementation. So, Avalanche, Polygon, there are a few dozen multi-billion-dollar protocols that kind of use the EVM. So you can essentially, use the graph to build out APIs on top of this data. So why would you even need to build out an API on top of this blockchain data? Why wouldn't you just query directly from the chain? Well, let's talk about traditional databases versus blockchains. Traditional databases are optimized for both read and write operations. So when you think about something like DynamoDB, it's very, very, very fast. You can write and you can read, and the latency is just very, very low. and therefore it's a great database for high throughput applications. And it works really well for the purpose that it's there for. And it's even probably one of my favorite databases. But when you think about blockchain data is not optimized for read operations. Instead, you hear about all the innovation happening around write operations. That is due to the nature of the limitations that blockchains have. Because instead of having data indexed for easy retrieval, data is instead written in these blocks of data that are kind of created over the course of time. So sometimes these blockchains are years old. So you have data that's been written over the course of days, weeks, months, and years. And if I wanted to then hit that database or that blockchain with a query that gets some relational data, it would almost be impossible, because I would need to understand that there has been transactions that have been written for all of this time, and they are not easily retrievable. So to kind of like go a little bit further, really, again, the innovation is around writing data. So you hear things like how many transactions per second a blockchain can handle, what is the latency of a transaction, and what is the cost of a transaction. So Ethereum is a very early, I would say, protocol that is not as efficient as some of the newer ones. I think something around 45 transactions per second, which is very, very inefficient. And therefore you have a lot of like innovation happening in Ethereum. They're going to be releasing like new versions that are supposed to bring it up to like 100,000, but still that's fairly small for a global execution layer. You also have other blockchains though, that there are literally dozens of blockchains that have multi-billion-dollar amounts of market cap and people using them. So there's blockchains like Solana that are like closer to 500,000 transactions per second. So I think like using all of these different protocols together, then we'll scale out to the amount of usage that people actually want. But we're still fairly, I would say, kind of early in the stage of scalability. And that's one of, again, the problems right now facing a lot of applications is like scalability. So how do we actually read this data then? If it's all like written in a very inefficient manner for reading, how do we to read this data? Well, in the past, developers would build out what are known as kind of like indexing servers. So they would something like how Google indexes all of the data in the world, and then they make it accessible via an API, like to kind of give you this information that they've gathered through crawling websites. Developers would build out these indexing servers that would store all this data on a centralized database, and they would then build out like their API layer on top of it. The problem with this though is that you're breaking like the important security principles around decentralization in the first place. So one of the main benefits of kind of like having a decentralized backend that is public is that you're guaranteed that this data integrity. So like you have this idea of a trustless infrastructure. Well, if someone centralizes this data and then serving it up, how can you trust that data? So the graph is basically there to solve that problem. It's a decentralized protocol that allows developers to build out these open APIs called subgraphs, deploy them to a decentralized network. And that network then replicates that API across multiple nodes, and it stores and then serves up that data via a GraphQL endpoint. And then anyone can kind of use that GraphQL endpoint to query data from whatever smart contract that they've built for. So the way that I'll talk a little bit more about the way this works, but essentially, you have the different people in, within this network playing different roles. And the graph network therefore has different participants. And this is kind of where tokens come into play. So like why does cryptocurrency exist? Well, it kind of blew my mind when I started diving into it to realize that a lot of them actually have some utility within a network. And in the graph network, we have graph tokens, and the graph tokens kind of like power and incentivize people to build out and own this infrastructure themselves. So in the graph network, we have 4 different main participants. We have indexers. These are typically infrastructure engineers that are running the actual open source software called the graph node that does this indexing of the blockchain data. They use the graph tokens to kind of run an indexer and essentially like put up some financial like deposit to be a participant in the network, and in return they receive a percentage of the actual query fees that are gathered by the network. So if you think of something like a serverless endpoint, we have like a Lambda function. We pay per execution, right? Every time we call a function, then we're going to be paying for that function to run. Something like that with a graph endpoint. When someone runs a query, then they are charged some query fee, and typically the app developer pays that. That goes to the indexer, and then that is how they get rewarded for their participation in the network. You also have subgraph developers. These are developers like myself that want to build an API on top of some data set. So if someone's built out a really cool smart contract, I might say, oh, I want to build out an API for this. So I'm going to kind of like create that API and I'm going to launch it on the Graph network. And I can then curate on that, which will kind of say, hey, I think this is a good subgraph and you should index it. So the indexers will then pick it up because it's been curated. And I, as a developer, can earn money based on the usage of that API. And then finally, we have delegators. And delegators allow people that have graph tokens to participate in the network without having to be really technical. They can instead find an indexer that is doing a good job, and they can spend some of their tokens to improve the indexer's amount of leverage to kind of be participating in that network. So instead of querying from a single endpoint that is kind of like a centralized endpoint, you now have the ability to kind of have this idea of a decentralized network. So once the subgraph is deployed and the data is indexed, applications can begin querying for that data without relying on a centralized service provider. And now instead, they're just relying on a query market that is comprised of a decentralized network of indexers. And all of these indexers are competing to provide the best service at the best price. So you're leveraging a network of people that are kind of like competing against each other to provide the best price for the query, I guess you could say. So that's kind of like one of the many different networks that are out there. You also have this idea of like off-chain data, because again, the only time you would really want to focus on on-chain data would be for like immutability or really important information. But you also might have less important stuff, or you might have things that do not need to be on-chain. There are a handful of different decentralized networks that offer some of the same characteristics in the sense that they are decentralized and probably a little bit more stable than a centralized, service, but they are not financially incentivized in the sense that you don't have to kind of like pay to store data there. So Ceramic Network is one good example of that. You also have services for all types of stuff that we've probably used on a day-to-day basis. So what about live streaming? LivePeer has a decentralized network that allows developers to build out live streaming services. The last time I checked, I think when I did some of the math and I talked to the founder, it was around 10x cheaper than using some of the live streaming services that you might see on AWS. And without going into too much detail, the way that this is made possible is that it allows people that have extra hardware resources on their infrastructure to kind of run these LivePeer nodes and use whatever additional unused capacity to kind of help strengthen the network and provide the service itself. And I've seen much more than 10x cheaper, but I think at a baseline it's at least 10x cheaper. You also have file storage. So Arweave is a really interesting file storage protocol that allows you to store an item once and it's available forever. So you store this piece of data, you can then retrieve it 10 years later, 50 years later, whatever. I'm guessing if the network's still around by then. But the idea is you just pay for a single transaction and it's now available forever. That's really cool to me because I like the idea of not ever having to pay hosting for something that maybe I'm not keeping up with anymore. You also have this idea of like decentralized Git hosting. So GitHub is a Git hosting service. Radical offers a decentralized version of that. And without going into too much around identity, We talked a little bit about identity earlier and how much different it is in the Web3 space versus kind of like what we're used to with handing over personal information. If you want to get a Web3 identity or a decentralized identity, you can download a wallet to kind of get started. I recommend either MetaMask or maybe Rainbow, and this will give you that public key and that address that you can use to start authenticating with different applications. And then if you do want to start interacting with websites and setting up user profiles and stuff and making those profiles portable, you can identify characteristics with your with your address using identity protocols, and IDX is one of those. And it's now more merged with Ceramic, which is what I mentioned earlier. And it essentially will allow you to associate like a profile picture or maybe a username or Twitter profile with your address. And you own that. You're the one that is able to change that data. And then other applications can access that directly from there. So you're not kind of changing it in a single database 100 times. You're instead changing it in this one network one time, and then every other application can then access that and use it. So you kind of have this like central place that you're changing your data, and all of these other networks then access that. So there is only a single point for you to kind of like make that update, and then it's shared between all the other applications. So when you kind of like put all this stuff together, like it's really close to what we're used to as far as like building a decentralized app, where we have like these building blocks of compute, identity, data, storage, and web hosting. And instead, we're now adding the addition of smart contracts. And a lot of the focus is around building this in a decentralized manner, making it a little bit more robust. So with that being said, I was going to build a demo from scratch, but I don't think I have enough time. Instead, I'm probably just going to go to maybe the graph.com and just show you how this works.
Nader, if you want to run the demo, we can tolerate the time actually.
Okay, we might have time to do that. So let me go ahead and see if we can't do that. I might be running through this a little quickly, but let's see here. And I know I need to increase my font size, so I'll do that. All right, so here I am in a empty directory, and basically what I want to do is build out one of these APIs that I was talking about. So I'm going to be running through some of this code because I don't want to take up too much time, but I will do my best to kind of describe what's going on. So we want to build an API. So like one of the cool places that I like to build APIs on top of are like these digital marketplaces, just because they offer like nice visuals. So this is like an NFT marketplace called Foundation, and it uses actually the graph already anyway. But the graph that they use is owned by them and stuff like that. But they also have a nice developer portal where you can kind of like look at their smart contracts here, and you can get the contract addresses and stuff like that. So like using this smart contract, we can now say, okay, we like their API. We want to build out our own front end on top of that though. So let's build out an API on top of their data, and then we're going to build out our own application. And even though that they have a nice UI, we have a better idea for how we might build a UI. So we're going to do that. So I'm going to go to the hosted service, which is kind of like a playground for building out subgraphs. And I want to go ahead and sign in. And I'm going to go ahead and create an API. And it looks like it's running slow right now for some reason.
Can it be because maybe like the login is having problems?
Yeah, let me try this over here real quick. Let me see here. Looks like we're having some issue. I'm going to try over on this other browser to see if there's any issue with what I have going on. If not, I can go ahead and maybe just go to some of our existing other APIs and do it there. All right, so maybe I'll just create one using this. We have basically two different ways. We have like that sandbox that I was using, which is centralized, and then it's kind of like a way to just to toy around. And then we have the actual network, which is the decentralized network, which is kind of like the Web3 version. So I guess this is the one that I will use since the other one seems to be having some issues. So I'll just like create a new subgraph. Choose Ethereum mainnet. And now we've kind of like essentially built out our boilerplate in the dashboard. And now what we want to do is kind of build out the code base for this using the graph tooling. So I can go to my CLI. Here I can say I want to create a new subgraph. I'm just pulling up some of commands so I don't have to like write these myself. So I can run graph init, and then I can say -- contract name. And this has to do with the actual smart contract. And in addition to like the foundation, I actually already have one documented for Zora, which is another smart contract platform. I'm sorry, it's another NFT marketplace that has their own smart contract. So either way, these are both like very similar. So I'm going to use Zora because I already have this code documented. So I'm not going to make any mistakes when I'm writing it. So so to get started, I'm just going to say graph init, pass in the contract name. I want to go ahead and pass in the contract address. So I can say -- from contract. And then this is going to be whatever that smart contract address is. And the way that you would get that smart contract address is like a couple of different ways. You can go to like in Foundation's developer portal, they have their contract addresses here, like I mentioned earlier. But there's also this explorer called Etherscan, which has a really ugly user interface. But you can also just like look for things. So here we have like Zora, and you can kind of see that the contract address is listed here, and you can kind of like get the contract information from Etherscan as well. So like there's a few different places that you can get the contract from. So we have that contract. I want to say -- studio because we have two services. One is the studio, which is the decentralized network, and one is the hosted service. And then I want to pass in one more flag called index events because we can either write all this code from scratch, or we can use some helpers that the CLI will kind of like allow for us. And if we go to the contract address and we go to the actual contract here, and this is another cool part about these smart contracts, is that usually once they're deployed, you can kind of just see all of the code here and use whatever code you want. The way that a lot of these smart contracts are built is that they have these events that are called within the code itself. So, you could think of this as something like a GraphQL subscription. So if I like create a new item in a GraphQL API, I'll often have a subscription set up on the front end somewhere so I can listen to that new item being created. In Ethereum or in the EVM, you have this idea of an event. So if you do some action, you typically invoke an event, and that event can be listened to on a front end application. And for us to be indexing this data, a good place to find out when new data is coming in is just by listening to all these events. And by passing in the index events into events flag, we can automatically introspect what's called ABI. It's an application binary interface. It's kind of like the API for this smart contract. And we can say, oh, there's like 10 different events. So we want to go ahead and create some boilerplate code locally for that. So we have that set up. We can choose the protocol that we like. Us is Ethereum. For the subgraph slug, we can just go ahead and copy this right here. The API directory, we'll just choose that. These are all the different networks that we support. So Ethereum mainnet, we also support Matic, which is like Avalanche. Which is Polygon. We support Avalanche. We support all these other ones. But mainnet is kind of like the main one, so we'll choose that. The contract address, we've already passed in that, and the token as a contract name. So this will essentially create some boilerplate code for us to start working with. And while that's creating, I'm just going to go ahead and open this up in my text editor and zoom in. All right, so once that is completed, we should see that everything is successful. We should be able to open up our text editor and see that the CLI has generated a boilerplate subgraph. And this is our API interface. And if you've ever written anything, which you probably have, like CloudFormation or any CDK, you're familiar with like YAML, and you kind of think of YAML as like configuration as code. And that's kind of what this is. Like the main entry point for understanding what is happening in your API is going to be all written in this subgraph.yaml, which is the configuration file. And you see that it's about 36 lines of code total. And this kind of is telling the indexer, when we decide to deploy this to the network, the indexer is running this software called the Graph Node software, and it will first introspect this subgraph.yaml, and it will look and see all the details of how they need to go ahead and index this information. And then this will be kind of like how they understand what's going on. So here you would do things like define the address that you want to index. So this is the smart contract address. You would define the ABI, or the application binary interface, which is the API that's written in JSON, which was automatically pulled down for you by the CLI. This isn't anything you really need to kind of like understand, but you could think of this as something like, in my opinion, kind of like a set of GraphQL queries, mutations, and subscriptions, where you kind of have like define all the different actions that can happen in your API. That's kind of like what you could think of that as. Like these are the actions that can happen in this smart contract. So we have that information. We have this mapping, which is mainly going to allow us to map these events to actions within our subgraph. Meaning, like when an event is fired, we want to call a function, and in that function, we want to kind of like do something, right? This is kind of where all that business logic would live. So like we'll look at that, all of the details of this in just a second. But there's three main parts like of a subgraph. You have the subgraph.yaml, which is the configuration. You have your data model, which is your GraphQL schema. And I will go ahead and kind of delete the boilerplate there because we're going to start from scratch. And then we have our mappings. And this is where we actually are going to be writing our business logic. So these three things put together kind of like make up the API. So going back to the subgraph.yaml, we are going to need to first define the entities that we want indexed. So these are essentially kind of going to be the data models. So right now we don't really have an idea of what those are going to look like. So let's go into the GraphQL schema and define the data models that we want to work with. And I think that the two that we might think of when we look at something like this, these are NFTs, they're non-fungible tokens, and they are abiding by this standard called the ERC 721 standard. And the standard defines kind of like the interface on top of one of these. And most of the time, you're going to see that it has an ID. It's going to have like an address for the owner and things like that. So we can kind of like model our data model around that standardization. And we're going to create a token type that has an ID. It has a token ID. It has a URI for where the content and the metadata live. It gives us a timestamp for when that token was created. And then we also have a creator and an owner. And these are essentially going to be relationships between tokens and users. So in addition to defining the token, we also have this user type. The user ID is just essentially going to be the address for the user. And then we create a one-to-many relationship between tokens that are created and tokens that are owned by this user. And then using our GraphQL query, we can get full text search. We can get relational data. We can do all types of stuff, sorting and filtering and stuff like that. So a basic GraphQL schema does not have @entity or @derived from. These are directives that we've added to the Graph API that allow us to define, first of all, an entity is going to be some data that needs to be indexed. So using this @entity, we can kind of like map this to this entities here. So that means we should have a token entity and a user entity. That just literally just maps directly from token and user. And then we have the way that we can map relationships. So here we have the @derived from, which maps a relationship between a user and a token. And this allows us to do kind of like user has many tokens, and then vice versa. A token has an owner that is a user. So with that being said, we're pretty much done there. We can close that out. The next thing we might want to do is take a closer look at this subgraph.yaml, because the events that we want to be able to handle might not be like all of these events. For a more complex API, you might want to handle like every event that is fired. But for this demo, we might want to know when a token is created, and then when a token is transferred, and then maybe when a token has updated their metadata. So using like that as our basic standard of what we want to deal with, we can actually delete most of these event handlers. So the two event handlers that we want to deal with are transfer. This transfer event will be called in the smart contract when a token is minted, and also when a token is transferred from one user to another. And then we also have this token URI updated, which is called when someone changes the URI of their token that they own. So using those two events, we can kind of build out a fairly decent API, I think. So with that being said, the next thing we might also want to do is here we have like our data sources. So like we're only really defining a single contract, but you can index multiple contracts within a single API. But in addition to the address, we can also pass in the start block, because going back to kind of what I mentioned before around how data is stored in a blockchain, like written over the course of all the time frame of days, weeks, months, and years, we might want to say, okay, we don't want to go back to the very launch of Ethereum network. Let's start at a certain block, like maybe when this contract was deployed. So we can just go and use this address and find the block from where this contract was originally deployed. And we can say we want to start indexing data there. So we're going to set the start block. So with those changes, we now have 27 lines of code, and I think we're done there. And then the last thing we want to do is our mappings. So in our mapping, we are going to be essentially saving data to the network. We're going to be reading data from these event handlers and then saving them to the network. Now, to make this a lot easier, we'll actually, I guess, to build this from scratch, we could kind of use existing APIs that are out there. But to make this easier, the Graph CLI can do GraphQL schema introspection and build out some code for us. So if we run graph code gen, then this should look into our GraphQL schema and go ahead and generate some code for us. So this generated some APIs that we can use to talk to both the graph node as it's saving information, but also to the smart contract itself. So if we go to generated here, we now see that we have this schema.TypeScript, and we also have this token. And using these APIs, we can essentially have a really nice way to talk to the node itself as it's saving data, and also to the smart contract, to the Ethereum network, I guess you could say. So the last thing we want to do is just go ahead and write this code. So the first thing we're going to do is we're going to go ahead and import some of the generated code that we had created for us. And really, the main things that we're going to be importing here are like 3 events for type safety. So we have the token URI and metadata URI and transfer events. This is just type safety stuff. And then we have the contract binding that will allow us to talk to the Ethereum network. So here we can like read data from the network whenever we need it. And then the user and the token will allow us to interact with and save information on the network, on the graph network, which is the graph node. So the first function that we want to deal with is, let's see here. If we go back to our subgraph.yaml, we have token URI updated. So we might want to have a function called handle token URI updated. So let's go ahead and create that function here. And we might want to say like if token. So here we have a variable called token, and we're going to try to load this from the graph node. And if that token exists, then we're going to continue here. If it doesn't, we're just going to return. And this means handle token URI updated mean we're updating the URI for that token. So that basically means we can just set a new URI and then save it back to the node. So token.save just kind of like saves that information back to the graph node and then exits. And then the other function that we have to deal with is handle transfer. That's this one here. So this is going to be fired when someone transfers a token or when they mint a token. So this is going to be a little bit more code because we need to go ahead and save a token every time this is fired. So this function will first try to load a token from the existing network, from the graph network. If the token does not exist, we go ahead and create it. So we create a new token using the token ID. We set the creator coming off the event and the token ID coming off of the event. We then bind to the smart contract on the Ethereum network, and we set the content URI, metadata URI, and create it at timestamp. We then go ahead and save the token here. And we do a similar logic here where if there is no user, we go ahead and create the user. If there is a user, we don't do anything. So I know I ran through that a lot, and it's probably confusing if you're not familiar with like Ethereum and stuff. But essentially, we are, having these listeners you could think of for when this event is fired, and when that event is fired, we're calling this function. We have some arguments coming through. We use those arguments to update our network information. That's kind of like where our main data source will kind of essentially be. So with that being said, we should be done now. So I should be able to kind of test the build out by running graph build. And if that builds successfully, I should now be able to deploy this. So if I go back to here, I can copy this deploy key to my clipboard. And I can say graph auth -- studio. And then this should prompt me for my deploy key. And then now I can run graph deploy -- studio, pass in the subgraph slug. All right, so if everything deployed successfully, we should kind of just see some output there. And if I go back here and I refresh, I should see that I have this playground now, and I should be able to like query. So if I can go here, I might say something like tokens, and we start getting data back. And if we go right here, you kind of see that the progress is 84%. That means like 84% of the data has been indexed. And we're already at 84% because we set a start block. So we're kind of like not starting from the very beginning. But we can also do other stuff. So I might say like order by token ID, and then order direction, be like descending. And we see that we have like, IDs that are higher up. So I might now check this content URI to see if it actually works. And I might check the metadata URI to see if this also actually works. And this content URI is, the item that was indexed, which is really something basic. So yeah, not a lot of fancy stuff there. Maybe we can try another one. See if there's an actual image or something. It's like these early ones were pretty basic. Oh, there we go. All right, so that was a lot, especially probably for people watching this. They might not be familiar with all of the Ethereum and like blockchain stuff. So I hope that wasn't like too much like over the top type of stuff, but it is cool to sometimes get a glimpse into other people's industries. And that's kind of it. So thank you for checking this out. And if anyone has any questions, I will be happy to take those questions.
Thank you, Nether. So I watched I couldn't actually count the minutes, so it was very immersive presentation and demo, and thanks a lot for that.
Yeah, totally. I'm trying to see how I can like stop sharing my screen. Okay, there we go.
Okay then. So like for me personally, it was very hard to digest. Not because that you are telling it fast or something, because I was kind of very new to this area. I think that it can be like this for the people who are watching, but let's wait for questions for a couple of minutes. There is like one person was asking when can we ask questions.
Yeah, for sure.
I think you must be also paralyzed now.
No, I'm happy to take questions. I have energy.
Yeah. So maybe in the meantime I can ask some questions. So let's say that I'm out from this session and I'd like to start building my own subgraph and everything. So what is the first the tutorial that I should visit, if not this session? So what's your recommendation about that?
Yeah, so I would say that you can go to thegraph.com and check out our docs. Check out our blog. We have a tutorial there in the blog. You can go to the YouTube, youtube.com/graph protocol. We have a video there showing how to do it. I have a blog post called Building GraphQL APIs on Ethereum that shows you how to do this on a different smart contract as well. There's a lot of content out there from people, from developers in the community that have created stuff. So if you just kind of Google around, you'll find a bunch of stuff. Definitely check out the website. There's a lot of documentation there.
Of course. Okay, so seems like we don't have questions, but as I say, I am sure that people are now shy to ask questions and they will reach out. So how can they reach out to you?
Yeah, check me out on Twitter, Dabbit3, or you can go to my YouTube/NaderDabbit, NADERDABIT. I have a bunch of videos on AWS stuff, but I also have a lot of newer stuff on talking about this area. And I've interviewed a lot of people that are building in this space. So I have to me, one of the better interviews was with LivePeer. So LivePeer was that decentralized streaming protocol that I mentioned earlier. That one was pretty impressive. I was impressed by the person that I was interviewing. Very, very eye-opening around how you might build something like this. So if you're interested, definitely check out that interview with LivePeer.
Okay, thanks a lot, Nader. And we are ending our conversation. Thanks a lot, everyone joining.
Thank you for having me.